this point you have a well-stocked toolbox of methods of integration. And as we were studying these methods, we applied them to various integrals, and it was pretty easy to decide which method to use because the problems we studied were associated to a particular section of the book. And in this section, we're not really going to study anything new. We're just going to practice deciding which method to use when faced with a problem in integration. Now, when you use these methods in later courses, most likely you're going to consult a table of integrals for basic integrals, and it's going to look like this. It's pretty standard. You have the power rule, you have the integrals of the well-known functions, e to the x, 1 over x, all of the well-known trigonometric functions, and at the bottom of this table it shows some integrals derived from trigonometric substitution or integration by parts. Beyond that, you're going to have to solve the integral using some combination of the methods that you've already studied, or maybe just one method. Now, having said that, there are a lot of integrals where our methods just simply don't apply, and for those we have to find some estimate of the integral. So in the next section, we're going to look at ways of estimating integrals, which is something we've already studied a little bit in Calculus 1, and at the end of the course we're going to spend a lot of time approximating functions by polynomials, and then of course you can approximate the integral of these functions by the integral of a polynomial. And this is a very important part of the course because for the most part these approximations are used in later courses to solve integrals and derivatives. As you approach an integral, it's good to have a creative or a problem-solving frame of mind, and it's good to keep in mind what tools we have in our toolbox in the background. Always keep in mind that it might be possible for you to simplify the integral by just simply rewriting functions. For example, the integral of cotangent of x, we can rewrite this as the integral of cosine of x over sine of x, and once we've done that, it's immediately obvious that the substitution u equals sine of x will make this integral very simple. It might be possible to simplify using a substitution and then applying a different method. For example, in the case of the integral 1 over x times the natural log of x to the 10, if I let u equals the natural log of x, this becomes the integral of 1 over u to the 10, and this is very simple using the power rule. If our integral involves mixed powers of sine and cosine, or mixed powers of tangent and secant, or a product of sine and cosine of multiples of x, then our standard methods for trigonometric functions are going to work. And of course, if we're trying to integrate a rational function, theoretically, our method of partial fractions always applies. However, you or even your computer might have problems factoring large polynomials or solving large systems of equations. You should always keep integration by parts in the back of your mind and always do a mental check to see if you can make that work. If you have something of the form the square root of plus or minus x squared plus or minus a squared, then a trigonometric substitution might work in your integral. And if you have something like the nth root of ax plus b, then a rationalizing substitution might work for your integral. You might also be able to manipulate the integrand and change its form so that one of your methods will work. Remember, we did this with the integral of secant of x. For secant of x, we multiplied by secant of x plus tangent of x divided by itself, and then the substitution u equals secant of x plus tangent of x actually worked. Your integral might resemble something you've already seen, and it's good then to think through how you solve that integral. Or maybe, as we said before, a substitution or a change of variable will convert it to something that can be solved by one of your well-known methods. For example, for the integral of sine of x times cosine of x times e to the sine of x, if we let u equals sine x, we get the integral of e to the u times u du, and this we can solve using integration by parts. So your integral might involve several steps or a combination of methods, and it's good to be prepared for this situation and persist in trying to solve the integral once you've changed the variables or once you've applied one method. So for this class, we're just going to work on a long worksheet of integrals, and as you work through the list, you should keep in mind that you're practicing trying to decide which method to use or how to solve the integral.